Hi kids, Mr Polley here. So today we're going to read a book called Forecasting. Now this is a non-fiction book. What will the weather be like tomorrow? Throughout history, people have tried to answer this question. Discover how weather instruments, satellites, and the fastest computers in the world help us to observe, track, and predict the weather more accurately than ever before. So non-fiction means this is not a story, okay? So this is all about how we predict the weather. So on the inside it says Jeanette Ellis, so she is the author. And it doesn't look like we have an illustrator because it should all be photos. So here we have the contents page. So again, I think these are the page numbers down here. And then it has a list of the topics we can find in the book. And then at the back it has an index, which shows us if we want to find some keywords in the book that we can go back here and see them on which pages. So for example, if we wanted to read about an anemometer, and then if we go to page 10. Interesting. I didn't know this word. I wonder what it's about, or what it is. So let's have a look at a few of the chapters of this book, okay? I think that it will take way too long to do in one go. So maybe we'll do half this week and then half the next week, okay? What is weather forecasting? Since ancient times, people have tried to predict or forecast the weather. It is not an exact science. Tools of the trade. Forecasting today uses the best of 21st century technology, artificial satellites, ground-based instruments, and the fastest computers in the world. They take weather measurements every moment of every day. Satellites track the bigger picture from above, whilst temperature, rainfall, humidity and wind speed are recorded locally. Meteorologists, people who study weather, and mathematicians create complex computer systems to make the most accurate forecasts. Do they get it right? Short-range 1 or 2 day weather forecasts are 85% accurate on average. However, it is still difficult to work out what will happen further into the future. Long-range 6 to 10 day forecasts can only predict very general weather patterns. It can sometimes be hard to give adequate storm warnings, since storms can develop, change direction, or disappear in just a few hours. A vital service. Weather forecasts are important for many reasons. For example, air and sea travel can be dangerous in poor weather. Farmers need to know what sort of season to expect, and people use weather forecasts to plan their daily activities. Meteorologists are also involved in education, teaching people what to do in weather emergencies. So let's have a look at the fact boxes over here, and then we'll talk a little bit about this page. Forecasting lifesaver. Early warning of extreme weather events like a cyclone saves lives and property. The first televised weather map was broadcast on November the 11th, 1936. It had captions. In the 1950s, people started presenting the weather. Everyone knew to bring their umbrellas today. Modern computers make today's 4-day forecasts as accurate as 2-day forecasts 20 years ago. Meteorology is the study of the atmosphere and weather processes. Okay, so there's quite a lot of information over here. So these are the things we use to predict the weather or forecast the weather. Artificial satellites. So those are things people launch into space that can watch the world from really, really high up. And we can use those to look at things like the direction the wind is going, or we can look at the way that clouds and the air moves in order to work out what's going to happen with the weather and where that particular weather is going to go. We have ground-based instruments as well. So those are things that measure the air, the temperature, the wind. And then we have computers as well, because often computers can take all of the information about the weather from over a long period of time and use that to guess what's going to happen next. So for example, the computer might see, every time it gets to this temperature and air wetness, which is called humidity, the amount of water in the air, it seems to rain in Hong Kong. So we can guess that if we see this information again, that it will probably rain, and the computer can do that really, really fast. Yeah, so look, we've got the word humidity over here, look, and humidity means the amount of water that's trapped in the air. So this is also quite interesting there. In Hong Kong, we often have typhoons, right, which is where it's very, very windy, and we have different numbers for those, right? So if there's a signal 8 or 10, then you don't go to school, your parents won't go to work, because it's dangerous outside. And this is where meteorology, learning about the weather, is super, super important, because it keeps us all safe, doesn't it? Even if it's just something as simple as make sure you get all your laundry back inside before it blows away. History of weather observations. Throughout history, people have observed and predicted the weather, often with mixed success. Ancient times. Thousands of years ago, the Chinese used cloud observation in weather prediction. They constructed cloud atlases, which detailed cloud shapes and colours and the weather they would bring. In 650 BC, the Babylonians included the halos around the sun and moon in their predictions. By the 3rd century BC, the Chinese had a calendar based on a 24-period meteorological cycle. That's a weather cycle. Each month had 2 periods with names such as the spring begins or the great rains. Around 350 BC, the ancient Greek philosopher Aristotle wrote Meteorologica, describing phenomena such as rain and hail. Wow, so even a really long time ago they were still learning about the weather like that. After 1400, from 1400 to 1700, the first instruments for monitoring the atmosphere were created. Nicholas of Cusa, a German, made a hygrometer to measure humidity. Around 1600, many scientists contributed to developing the thermometer to measure temperature. Temperature is a big part of weather, so measuring it is important for forecasting. In 1643, the Italian physicist Evangelista Torricelli invented the barometer. He discovered that mercury, which is a type of liquid metal, responded to changes in air pressure and could be used to measure it. Barometers can also measure air pressure using water or a small flexible metal box called an aneroid cell. Well, I think that gives a lot of information and terminology about barometers without really saying how they work, doesn't it? Modern weather observations. The invention of the radiosonde, an observation instrument carried up into the atmosphere in a helium-filled balloon in the 1920s, made observations at great heights possible. So the order of this fact information should be a little bit more about the information here. So let's see. Did you know? Aristotle believed that everything was made of 5 elements. 4 earthly elements, earth, air, fire and water, and as it says wind and fire, earth, air, wind and fire, and a 5th divine substance, ether, which makes up the heavenly bodies, i.e. stars and planets. Today, satellites in space allow observations from even greater heights, far above Earth. Complex mathematical models use this data to create reasonably accurate forecasts. Many years ago, weather warnings were sent from city to city by a rider on horseback, so the weather usually arrived before the warning. Radiosondes in weather balloons transmit air pressure, temperature and humidity and wind information to a receiver on the ground. Okay, interesting. So let's have a look back at this stuff over here, shall we? So this is interesting. This, what is it, the 24-hour period meteorological cycle. So actually, I believe that this goes over the entire year. So it would have very general information like, oh, in winter it will be cold, in spring it will be rainy, and if you think about it, that seems very, very simple, right? Like we all know that these things are, it's going to get hot in summer. But this was in 3rd century BC. So that means that's before our current year system started. So this is 2,300 years ago-ish. 2,300 years ago was when they figured this out in China. Interesting. And we also have Aristotle here, who is around a similar time. It says 3rd century BC, so that's also around this time. We have Aristotle in Europe, and he's talking about rain and hail. But Aristotle really didn't understand things very, very well, because he, as we see over here, he just believed everything was made of earth, air, wind and fire. So he would say something like, oh, you know, the rain is made of air and wind, which is of course ridiculous. But he would try to describe things, which is, you know, quite a lot for such ancient times, isn't it? I also think it's quite funny. You imagine if the horseback rider rides into town and says, hey, it's going to rain tomorrow. It seems very slow, doesn't it? Okay. And that wouldn't be particularly helpful for like disasters, like if there was a typhoon coming, right? You probably want to know earlier than that. So anyway, I think that we are finished with this difficult book for today, and we'll come back to it next week. I hope you found it interesting, and I'll see you soon. Bye kids!